Hi everyone, and welcome to Raspberry Pi After School Online. My name is Pat Kerrigan, Executive Director of the Oak Hill Collaborative. For the next 6 weeks, friends of the Collaborative are going to be showing you all the amazing things you can do with your own personal computer. With the help of our presenters, you will think like a computer, know all the parts of a computer, and even learn how the internet works. For the first couple of weeks, this program will help you learn some basic computer science. Then, come week 3, you'll even get your very own CanaKit Raspberry Pi computer to assemble and use in the following weeks. But before we get to that point, let me hand it over to my friends who will share their knowledge on computers and technology. Let's begin.
Hi everyone, and welcome to Raspberry Pi After School Online. My name is Michelle Fleming, Mechanical Engineer and Industrial Robotics Teacher at Academy for Urban Scholars. Today, I'm with Oak Hill Collaborative and Success After 6, and I'll be introducing you to binary numbers and how to think like a computer. Before we start, however, we need to make sure you got everything in the mail that you should have this week. Normally, you would get them in class, but as part of this online program, all things will be mailed to you instead. We've got the Parent Guardian Guide. Now, this guide has tips and guides on how to take pictures of the assignments, engage with your child's assignment, and answer keys to the assignments to check their work. You have the pre-assessment. It is very important that the pre-assessment is completed and then snapshot and emailed back to the address found in the Parent Guardian Guide. These results are used at the beginning and the end of the program to show progress. You have a QR code to watch this video, and if you're watching it right now, then you already have it. You have a binary assignment, and we'll explain this to you in just a bit. First, let's talk binary, which is how a computer thinks. When you or I think about something like a dog, for example, we think in words and images. So when you imagine your dog, you think of words like woof or fetch. But when a computer thinks, they process ideas in the form of math and numbers. This is known as a base 2 number system. That's because only 2 numbers are used, 0 and 1. This makes sense when you think of binary as 2 words, bi meaning 2 and nary meaning together. Computers are simple thinkers. They only need 2 numbers to get the job done. Now, we as people operate with a base 10 number system called decimal. Deci meaning 10. This is because we have 10 fingers and figured that that would be a good stopping point. So, when you try to communicate in binary, you have to translate from base 2 to base 10 and base 10 to base 2. We're going to demonstrate how you can do that today so that you too can think like a computer. In this week's lab, we're going to start by looking at the decimal system, then we'll examine the binary system, and then we'll start working on counting in binary. You probably remember talking about the decimal system in school, even if you don't quite remember what it was called. You took some time and looked at the ones place, the tenths place, the hundredth place, the thousandth place, and so on. We're going to start by putting a number in the decimal system, just so we can recall what using the decimal system looks like. I'm choosing 4, 3, 2, 1. So we're going to start in the ones place. 1 times 1 is 1. 2 times 10, the tens place, is 20. 3 times 100 is 300. And 4 times 1,000 is 4,000. Now, to simplify this, we're going to add these numbers together. 4,000 plus 300 is 4,300. 20 plus 1 is 21. And then we're going to add these numbers, and you get 4,321 using the decimal system. Now, our next step is to look at binary patterns. That way we can practice, figure out a few binary numbers, and then we'll be able to do a binary example. Now we're going to count to 6 in binary. When you look at the binary system, I want you to think of zeros and ones like off and on switches for number places. 0 meaning off and 1 meaning on. So let's start by looking at number 1. So I have this number 1 right here, and I'm going to try and recreate that number 1 in binary by looking at my places. Now let me tell you, when you're using a binary space, these numbers increase by doubles. So if you have space 1, if you were to double space 1, you get 2. If you double 2, you get 4. If you double 4, you get 8. If you doubled 8, you get 16, and so on. But we're just going to look at these numbers right here to keep it simple for now. So let's start. I've got number 1. So I'm going to put a 1 in the ones place. And that's the only place I'm using because I only need 1. 1 times 1 equals 1, of course. So my answer for number 1 is 1 equals 1 as the placeholder in binary. It kind of looks like our numbers in the decimal system, but I want you to remember that it's not quite the decimal system on the opposite side. It's a placeholder. So now let's look at number 2. I've got these 2 slots. I've got 2 and I've got a 1. I only need the 2. So I'm going to start by turning off the 1 spot and turning on the 2 spot. So we've got 2 times 1 plus 0 times 1 because the 1 spot is off. And there you've got 2 equals. Now, like I said, it may look like decimal, but it's placeholders. So that means you have a 1 and a 0, also known as 10, for your number 2. All right, so I'm going to erase this, give us a clean slate, and while we're looking, you can start to take a moment and guess number 3. So the next number we're going to solve is binary number 3. We'll look at placeholder 1 and placeholder 2. 2 plus 1 is 3. So that lets me know that I need both the 2 spot and the 1 spot turned on. So I'm going to turn on spot 1 by putting a 1 in, and I'm going to turn on spot 2 by putting a 2 in. Now, if you need to check and make sure that you've got this number right, we're going to say 2 times the 1 that we've placed in the spot is 2, plus 1 times the 1 we've placed in the spot is 1. 1 plus 2 is 3. And then you're going to take those numbers in the spaces that you've turned on, and you've got 3 equals 1, 1, or what we would consider to be 11 in our decimal system. But don't forget, it's not really the decimal system when you're looking at binary. All right, now let's take a look at number 4. You can take a moment and try and guess or anticipate what you think the number 4 might be. But let's start by looking at the number places that we have. We've used place 1, we've used place 2, and if you were to add those numbers together, you don't quite get 4, you get 3. So we're going to have to add this next slot, which is a 4. 4 plus 2 plus 1 is 7, which is higher than the 4 that we need. So we're going to turn off the slots that we don't need and just use the ones that we do to get the correct binary number. Now I know for sure I need 4, so I'm going to put a 1 in that 4 slot. I don't need the 2 because adding that makes it more than 4. And I don't need the 1 because adding that makes it more than 4. So if you want to run a check, like I said, you're going to take these numbers and add them together, and you get 4 plus 0 is 4. And then you're going to take the binary placeholder numbers, and you get 1, 0, 0. So number 4 equals 1, 0, 0. That's 4 on, 2 off, and 1 off. All right, so the next step is number 5. And I would like for you guys to try and anticipate or guess what number 5 might be while I make space to solve the next problem. All right, so number 5. We've already talked about how you can add these numbers together to try and come up with your place. Now, if you look at 4, you know that's not enough for 5. If you look at 8, that's a little bit too much. So let's start with 4 and add one of these numbers to get 5. So if we do 4, we know we're going to keep that. We're going to put a 1 in the slot. 4 plus 2 is 6. That's too much. So we're going to turn off number 2. But 4 plus 1 is 5. We're going to turn on number 1 by putting a 1 in the spot. Now, to run our check, we're going to do 4 times 1, 4, plus 0 times 2, 0, plus 1 times 1, 1. Add them all together, and you get 5. Now, because we know that's 5 like we want it, we're going to take our binary placeholder numbers. And then we know that 5 equals 1, 0, 1. All right, now, while I clean up the screen for number 5 and move on to 6, I think it's a good time to teach you a little bit of a trick you can use depending on what number that you're looking for. There's a trick that you can use to look at a pattern or create a pattern for number 6. We're going to start by using that trick, and then I'm going to explain it to you the way we've been using the whole time. Now, when I look at my screen right here, we talked about adding these numbers so that you can determine whatever number this is, and then using your binary placeholder. Well, in this case, we've used 4, we used 1 for 5, and we know that one more to 5 is 6. So we had 1, 0, 1 for number 5, and like I said, now we're using 6. 6 is just 1 more than 5. If I look at this slot, I know that 2 is 1 more than 5. What I can do is take this 1 right here and slide it over to this slot because I now need 2 instead of 1. That means I would now turn off the number 1 slot and put a 1 right here in the 2 slot, and then I'd still use a 1 with my 4 slot because I still needed the 4. At that point, you'd have 6 equals 1, 1, 0. But we're going to go back and use the same check we used for the other system so that you can understand that these numbers work the same way using that pattern. So let's go back to how we've been doing this the whole time. I have 4, 2, and 1. I know that 4 plus 2 plus 1 is 7, which is 1 too many. I know that 4 plus 1 is 5, which is not enough. So I'm going to use 4 and 2 equals 6. So now that we've done the number 6 using our trick, we're going to go back to doing it the way we've been doing it all along, just to verify that this actually works. So I'm going to start by looking at the places. 4, 2, 1. I know that 4 plus 1 is 5, so that's not quite big enough to equal 6. But I know that 4 plus 2 equals 6, and so I'm going to take those numbers and multiply out with the slots that I have turned on. So I'll say 4 times 1 is 4, plus 2 times 1, 2, plus 0 times 1, 0. 4 plus 2 plus 0 is 6. So on the binary side, again, just like in our trick, I've turned on number 4. I've turned on number 2. I've turned off number 1 because I don't need it. We're going to take these numbers. If you look at the numbers in pink, you've got 1, 1, 0. If you look at the numbers in blue, using the way we've been practicing the whole time, you have 1, 1, 0. So when we've done our check using our trick and using the normal way that we've done this, you got the same number. 6 is 110. And that lets us know when you slide a number to the left, depending on which binary number that you're looking for, you're still going to get the same answer that you're trying to get. All right, so our next step is going to be to practice with an example. So if you're at home, I want you to take your paper and create the binary places. We have 8, we have 4, we have 2, and we have 1. We're going to practice by using all of the slots so that you know what it's like to create a larger number. So I'm going to turn on the 8 spot. I'm going to turn off the 4 spot. I'm going to turn on the 2 spot, and I'm going to turn on the 1 spot. We're going to add these up and come up with which binary number this is. So as we did before, we're going to multiply these numbers out, the numbers that we've turned on and off, to come up with a total. 8 times 1 is 8. 4 times 0, which is turned off, is 0. 2 times 1, which is turned on, is 2. And 1, also turned on, 1 times 1 is 1. Now we're going to add all of these together. And we've got 8. 2 plus 1 is 3. 8 plus 3 is 11. What this means is that the binary number 11 looks like 1011, or what we would call 1011 in our decimal system. But you want to remember that it really means place 8 is turned on, place 4 is turned off, place 2 is turned on, and place 1 is turned on. And now that you've had some practice and some examples and learned some patterns, you can go ahead and work on your counting in binary assignment and try and give yourself some practice. If you need some help, feel free to go ahead and restart this video and practice again. And that's all we have for you for this lab. This week's lab assignment is counting in binary. Now that you know how to count in binary, you'll be counting from 1 to 63 using binary. Some answers are already given, and these should be used as checkpoints. Parents, you should have an answer key in the Parent Guardian Guide, and it only may be used to check your child's work. Now you can pause the video, and good luck. Welcome back. How did you do? If you didn't get them all right, that's okay. We're so good at thinking like people that thinking like a computer doesn't always make sense. Make sure you fill out your pre-assessment if you haven't already, and have your parents email those to us using the email provided in the Parent Guardian Guide. Next week, you'll be joined by instructor Sarah Natson, who will be walking you through what all the parts of a computer are. Until next time, this has been Michelle Fleming, mechanical engineer and robotics instructor with Oak Hill Collaborative, signing off.